Hello, this is the Tepid Coder. In this video, I want to talk about some little gotchas with standard vector. So, iostream vector int main. So we have an entry point at 0. Let's make a standard vector of something really simple. Let's say vector of ints, not tents, just ints. Okay. So now what I want to show here is there's different constructors you can call with vector. Now, I've been using the default constructor in almost all cases in the videos I've done so far, but there's one you can do that has a size t, it's st element count, right? And over here you can also specify an optional value, so like t value, let's say some type value. In this case it'd be int, so maybe I value. And then you can also do some kind of allocator that handles how things are allocated. That's also defaulted. So if I just did this, some count, it's going to construct that many elements, and I could just access them right away. Let's say I want to have 10 elements, and I want them all to have the integer value x. Right? I can do that. That'll work just fine, because x is just a number. It's 120, I think, in decimal, or 78 in hex. Okay, so let's actually show that real quick, that this is going to work. Standard cout, we're going to say value, okay, we're going to say I for integer, inline. Let's do this for each integer inside the vector. So const auto I from vec. Yeah. And let's try and compile that. So I'm going to do g++ test.cp out test, not tset. Test. Okay, there we go. All in 20s, like I said. So I'm going to rm tset .exe, I guess it would be, verbose. Yep, good. Alright, so now what I want to show is there's different kinds of constructors for vector. If I have something like namespace, std, right, and inside of here there's like class vector, right, it's a template class, template, type name t, right, except lowercase, you know, dot to dot, whatever. Down here you have your implementation, so I'm going to steal this over here, copy that, paste it, let's say standard vector of some type t, vector, default constructor, right, dot to dot. Okay, and you have some other one. This is like vector, but it also takes a size t and element count, and it also takes an optional value put in there, right? So I'm going to say the next line here, t, say t value, maybe even const, right? Because you can do a const reference and it'll work just like a t value like this. Okay, so it has a constructor for that. But then we run into a problem because we have a standard vector of type t. Let's paste that back on there. Nope, that's not what I want. I want this. Okay. And then we have vector. And this one is going to take a standard initializer list. Initializer list, yep, of type t. Type name. You have to do that when there's a container of something instead of just the type itself. Okay, and it's going to be initializer list. So now what's going to happen here is when you're using the curly brace syntax to construct, instead of the parentheses like this, you're going to be calling this initializer list version. So I'm going to show that. What we're really going to get here is a vector initialized with two values of type t. Each of these is going to be treated as an integer value because they've been inverted to that, and it's going to push both these into the vector. So I'm going to value 10 and the value 120 instead of 10 120s. Okay, so let's do that real quick. Chill that off. Let's say, okay. Cool, so 10 and 120. So you need to be careful to only use the curly brace way of constructing when you're actually intending to use an initializer list. It'll work for both, but if there is an initializer list version, it's going to actually call that. And you can actually look at the documentation here, and you can see what kind of constructors it has. We can see if you do nothing, it's going to just have a default constructor. You can also do something with a allocator here. You can define the way that it creates elements yourself. I don't really want to get into that right now, but here's the one I was showing here. We have the count you want to initialize with. If you just do that, it's going to have the default value for everything. It's going to call the default constructor for that type, right? And if you actually specify a value, it's going to stick that value in there, and it's going to do that for each of the count elements that it puts in. If you put in 10 elements, it's going to call it 10 times. You can see it right here with the actual value. This is actually constructing something, right? Okay, you can also do that with an allocator in both cases. Yeah, count right here, which I mean is kind of interesting because you already have these defaulted, right? So it's kind of redundant they're putting this here, I think. Although they are showing the version you could do it. This one has like 14, right? Anyway, it's like you can also construct with an iterator first and last. So if you have a vector that already exists and you want to take a slice of that vector, you could actually pass like an iterator to some starting position in that vector you want to copy from, up to the ending iterator you want to stop copying at, not inclusive, and you can construct a new subvector out of that, basically. And you can do a copy constructor on the vector. You've seen that before. You can do that with the custom allocator. You can do a move constructor on the vector from another vector. You can do that also with a custom allocator. And here's the initializer list right here that was causing problems. Well, I knew about it, so it didn't cause problems, but it could have, right? Anyway, so just keep that in mind. If you see initializer list in any of these classes that you're using, you need to be careful to ensure that's actually what you want to use. Because if it isn't, you know, you're probably going to want something like this or that, right? Anyway, something else I want to show now. I'm going to void test user one just to preserve the code and have it not function here. Let's take that out of there, stick it in here. Okay, now let's say I have a vector that has some elements I want to get rid of. Okay, I'm going to just initialize it with the values, say, 0, 1, 1, 1, 2, 3. Now, I've shown a way before where you can erase it. If I do, say, vec.erase, I know that this is at offset 1 right here. This is 0, this is 1. So I could say vec.begin plus 1. And that would erase the first 1 there. But what if I want to get rid of all the 1s? I would say while vec position 1 is equal to 1, right? Because every time I erase, all this stuff's going to slide left like this, right? So this should work, and I'll show it. But there's a different way you can do this. Integer from vector. I'm going to say standard cout remaining value. Put that in a string, huh? Jeez. Brain died there for a second. Okay, let's try that. Okay, 0, 2, 3. You can see it worked. Now, there's a different way you can do that by deleting it while you're looping through using iterators. And for this, you have to be a bit careful. So let's say I'm doing standard vector, some type, it's t. I have iterator, because I'm going to be messing with it. Iterator, it equals vec.begin. Okay, now it does not equal vec.end. So we haven't hit the ending point, it++. Now, you have to be careful with this. Let's say I say iterator, it, the value at that iterator is 1. Now if I simply just say vec.erase here, I erase it, that's actually going to be undefined behavior right there. When you erase something, the iterator becomes invalid. So let's actually show that real quick. So iterators including the end iterator and references to the elements at or after the point of the erase are invalid. So that means, since this is at or after the place that I'm erasing, it is invalid. But luckily, vec erase actually returns an iterator, so it equals this. Now there's something else we have to consider too. Every time we delete something, remember, stuff's shifting this way, towards us. So if we increment to the next thing, we're going to be over here now. We're going to skip that first one. Then we'll delete this one, and then skip ahead to like the 3 and we'll end. I don't want that, so we're only going to iterate if we need to. So this, else, we're going to say it++. it++, okay. Let's try and run that, so, okay. I didn't actually print it out, is that what happened? Yeah, I never actually printed it out again, oops. So for const auto int reference from vec, come on, vec. Not return, jeez. And my brain is dying right now. Sorry about all that. I'm going to say remaining value. Okay. And there we go, 0, 2, 3. So that's defined behavior and it's all well and good. Now typically I wouldn't use an else here. What I would probably do is I would just say continue if we deleted something. And then otherwise this code can run. Because if this continues, we're already back up at the top. So that way you're not pushing everything to the right so far. So I'll show that real quick. Something else I'll show while we're doing this is that while you're using iterators, you can actually show how far into the vector you are. So if I say something like, what do I say, current offset, I could do it minus vec.begin, right? You're allowed to subtract those like that. Standard window. Okay. There you go. So you can see current offset stays at 1 while it's deleting them. So that's kind of funny. And then here's the 3, and here's the, no, this would be the 2 then 3. So 0, 1, 1, 1, 2, 3. But see, the 2 got pushed here, and 3 got pushed to the second, because everything kept sliding back to the left. Now, there's a more compatible way of doing this. Instead of doing it this way, if I was using a standard list, you can't do random access, and you can't just subtract these iterators as far as I know. I don't think that'll work. But what I know you can do is you can use this function, an algorithm called standard distance. And what you do is you pass it to begin, comma, the end. So it'd be it is where we're ending at. Okay, let's try that. And this should work with, I think, all container types. And there we go. So that worked as well. Just keep in mind when you're calling constructors of a class you didn't create, or even if you did create it and you haven't looked at the code in a while, pay attention to the constructors to make sure that you're calling the right type of constructor if you're going to use the curly brace notation. In general, I would say don't use curly braces unless you're going to use an initializer list to initialize your class. If you know for sure that you want to just call a constructor that takes some arguments, use the parentheses instead. And if you found this video useful, give it a thumbs up. Consider subscribing for more content like this. If you have any comments, suggestions, criticisms, off-topic thoughts that are just interesting to you, feel free to post them in the comments. I have low volume of those right now, so I usually read everything I get. And I suppose I'll catch you guys later. Have a nice day.